everybody. We're going to be talking about target number 6 from today's test today. And target number 6 is about an isosceles triangle that has side lengths 17, 17, and 16, and a point inside the triangle is a distance of 1 unit away from both of our longer sides of length 17. And we're trying to find the shortest distance from the point here to the side length of 16, which is the base of our triangle. And we're going to be expressing our answer as a common fraction. So I would start by divvying up this triangle and labeling its sides. So instead of a 17, 17, 16 triangle, I would draw lines from our point 1 unit away from each of our 17 length sides down towards these vertices, creating 3 new triangles. So we have our smaller blue triangle, and then we have these 2 identical triangles here in between the blue triangle and the red triangle. Now, the first step would be to find the height of the red triangle. So going from here all the way down to the base of the blue triangle, and we can use the Pythagorean theorem to do that. We know that if we look at this half of the red triangle, the hypotenuse is of length 17. We're trying to solve for the height, so we'll call that h. And the base is half of the base of the entire red triangle, so that's 16 divided by 2. And then simplifying, we can say that 17 squared is 289. And then 16 divided by 2 is 8, and 8 squared is 64. So height squared must be 289 minus 64, which is 225. And if we have our squares multiplied, which I highly recommend everybody do up through at least 20, we know then that 225 is 15 squared, and now we know the height of our entire red triangle. With that information, we would want to next find the area of the red triangle. And since we know the height and the base, we can use our area of a triangle formula, which is 1/2 base times height, and say that 1/2 times 16, our base, times 15, the height, is 120. I would do this by dividing 16 by 2 to get 8, and then 15 times 8 is 120. Now let's look at these smaller green triangles we have here. There's 2 of them. And with these smaller green triangles, we know that their side length is 17, and then the altitude from this vertex here to the red side is of length 1, because they tell us the triangle that the point is 1 unit away from the side lengths of 17. So the area of those triangles are 1/2 times 1 times 17, or 17 halves, and we get that from our area of a triangle formula. And then since there are 2 of them, the combined area of the green triangles is 17 over 2 times 2, which is 17. Now, we have a lot of pieces coming together here, and our next step is to find the area of the blue triangle, because now we know the area of the overall red triangle and of the green triangles that fill up the space in the red triangle that's not the blue triangle. So using subtraction, we can find that the area of the blue triangle is 120 minus 17, which is 103. And from here, we're able to solve the entire problem because we know that the area of a triangle is 1/2 base times height. And if we look at this blue triangle, the value we are trying to solve for is the height of the blue triangle, which is the distance from the point to the base, or the side length of 16. And we look at our area of a triangle formula, we know the area of the blue triangle, we know the base of the blue triangle, so there's only one variable left. So we can go ahead and plug in the area of 103, the base of length 16, and then we leave the height as a variable. And when we simplify, we get that 103 is equal to 8h. So the height of this triangle is 103 over 8. So the distance from our point to the base of the triangle is 103 over 8. And that is the answer to target 6.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.